Hello, and thank you for coming to SIG School Scholars. Today, we'll be looking at linear functions as well as linear inequalities and systems of linear inequalities. So, first we'll call that a linear equation is a polynomial of degree 0, or 1 or less. A polynomial is an expression that contains coefficients as well as variables, and it involves addition, multiplication, subtraction, or division. And there are no negative integer exponents. So, example, this expression is a polynomial, whereas this expression is not a polynomial. Because it has both a negative exponent as well as a non-integer exponent. So, now a linear function is a polynomial of degree 1 or less, and the degree of a polynomial is the exponent of the greatest exponent of all the terms. For example, the polynomial has degree 3 because 3 is the highest exponent value of any term in this equation. The polynomial 2x plus 4 has degree 1, and the polynomial 4 has degree 0. So both 2x plus 4 as well as 4y equals 2x plus 4 as well as y equals 4 are linear functions. So, a linear function can be written in this form, is often written in this form, y equals mx plus b form, where m and b are constant. M is slope, or the rate of change of the function and at a certain point, and b is the y-intercept, or the y value at which it intercepts the y-axis. So let's do an example. Let's look at an example. Y equals 2x plus 4. So this plus 4, the positive 4 is the y-intercept. It's the constant term b. So it intercepts the y-axis here. Because if we put x equals 0 into this, we get y equals 4. So we know that the y takes on the value 4 at the input 0. And let's see. The function, the linear function, looks somewhat like that, passing through these 2 points. This is at y at 1, the function takes on the value 6. So this is the point 1, 6, while this is the point 0, 4. I pass through both those points. So a the slope, often called rise over run, is average rate of average rate of change. However, for a linear function, the slope is constant. So what the slope of 2 means is that for every x value it goes over 1, it goes up 2 in y. So to find the slope, the formula for slope, the slope between 2 points, is given by this formula. Rise over run. Or delta y over delta x, which means a change in y over a change in x. So if we put these values in for y2 and y1, x2 and x1 in the equation, we'll see that our slope will end up being 2. So let's try it. y2 is 6, y1 is 4, x2 is 1, x1 is 0. We get 2 over 1, and so the slope is 2. And we'll find that slope if we take any 2 points on this line. Okay, now that we've looked at linear equations, we understand them. Let's go ahead and look at linear inequalities. Yes, but before we move on, it is probably necessary to note a few more things. Okay, this y equals mx plus b form is called slope-intercept form. However, what is called the general or standard form is written as ax plus by equals c and the point slope form is written as y minus y1 equals m times x minus x1. And the logic can be seen in this one. Let's look at this one first. So y minus y1 equals, now we know m is y minus y1 over x minus x1. That's the formula. And this is saying that times x minus x1 will be y minus y1. Well, these would cancel out, and that's what you would have. And this basically states the relationship between changing y and changing x. So the difference in the y is proportional to the difference in x, where the that proportionality is the slope, which makes sense because remember from our example, where the slope was 2, the y increased by 2 as the x increased by 1. That was the proportionality. A change in x of 1 yields a change in y of 2 because m was 2. Now, let's look at the general or standard form. Well, let's go ahead and erase the y equals mx plus b form. We've already looked at that. Or slope-intercept form, as it is actually termed. Now, if we're looking at the general or standard form, this is the general or standard form for a linear equation. Now, we can still discern the slope and y-intercept from it, however, and we can see how, it is equivalent to y equals mx plus b. So a and b are both not 0. Well, and let's look at this. Ax plus by equals c. So, we rewrite this. By is equal to c minus ax, and y is equal to c over b minus a over b x. So, let's see. So this would mean, based upon, this would mean that, well, let's look at this. If we put 0 in for our value of x, and we see that c over b is the y-intercept, because that's what the y-intercept is, the value of y when x equals 0. C over b is our y-intercept. And our slope, m, is equal to negative a over b. Let's see. And the x-intercept, the value of the function at which it crosses the x-axis, or when y equals 0, you can find that as well. Y 0 will equal c over b minus a over bx. So then go to c over b equals a over bx. And final and finally c over b okay, try this again. And finally, c over b times a over b, times b over a, because we're dividing a over b. C over b times b over a is equal to c over a. So c over a will equal our x-intercept. So, that is linear functions. Now let's look at linear inequalities. So When we write linear functions, we write something such, for example, y equals 3x plus 2. However, in a linear inequality, y is not necessarily equal to the function. We may have y is greater than, let's write it this way, y is greater than ax plus b, y is less than ax plus b, or y is less than or is greater than or equal to ax plus b, and y is less than or equal to ax plus b. So in order to graph a linear inequality, well, let's see. We'll do it this way. Well, it may be better to write this in the standard form. Let's do it that way, the standard form. Right, ax plus by. We can write it either the standard form or the slope-intercept form. We can write, so we can also write something such as this. So let's look at an example and how we would graph it. So let's say we have the linear inequality, 6x plus 3y is less than or equal to 12. Now, what we're going to isolate our y. So we'll subtract 6x from both sides. So we'll have 3y is less than or equal to 12 minus 6x, and then we'll divide by 3. Y is less than or equal to 4 minus 2x. Or negative 2x plus 4. So let's go ahead and graph this. So we know that 4 will be our 4 here will be our y-intercept. And negative 2 will be our slope. And at 1, the line will be 4 minus 2. It will be 2. So the line y equals 4 minus 2x. We'll graph that line first. If we put in 1 for x, we get 4 minus 2 is 2. 1, 2. We'll draw that point here. It's probably better. And this negative slope shows that the function decreases as x increases. And this is how it will look. Something like this. So probably a little straighter. So now there's to take care of the y is less than or equal to that. So what we're going to do is we're going to shade the half plane that is less than y, then the line. So y is less than 4 minus 2x means that it lies in the region that is always less than the value of that on the left side of it, as you can see. So y will lie in this shaded region that will go on forever, because it will extend upward and downward and forever, and sort of in this direction forever as well. So let's look at another example. Let's say we have the linear inequality. Y is greater than, oh, here, let's write it this way. 8 is greater than 2y plus x. Now, again, subtract x from both sides. We have 8. Well, here, I'm going to change the function. Let's change the inequality a bit to minus x. So 8 plus x is equal to let's write it. Let me write this again. We'll change it. Eight less than 3x plus 6y. Well, 9 is greater than 3x plus 6y. Let's add 3x to both sides. 9 plus 3x is greater than 6y. Divide every term by 6. What we have is y is less than 9 over 6, which will be 3/2. Plus 1/2 x. So, let's go ahead and graph that one. Well, the y-intercept is 3/2. See right there. And if we add 1/2 to that for the y value at 1, we'll have 4/2 or 2. Put that here. We'll have a line that looks like that. Now, y being less than that, we'll put it down here. However, and y being greater, that would put it above the line. However, the problem we have is that we didn't quite do this correctly, because it's saying that y is less than, not less than or equal to. So what we do to revise that is that we draw the line as a dotted line, because y will take no value that is on the line. Unlike in the previous example, it could take value that was on the line, but in this one it cannot, so we'll just make that a dotted line. That's how it does work. Now, let's look at a couple of systems. These are nowhere near as involved as the other as systems of linear equations. Gladly. Well, let's say we have the system y is greater than 3x plus 4 and 8 is less than, or is greater than, I mean, let's say 2x minus 4y, 5y. A y greater than 3x plus 4. Let's draw that. Okay, let's say this is 4. 3 plus 4 is 7. Put that around here. This line is here. I'm gonna have to dot this one. Let's go ahead and make it dotted. So there you go. There's a dotted line. Now, let's go ahead and draw the other line, except let's use a different color. So let's change the color for this. Whoa. 8 is greater than 2x plus 5y. Let's see, how do we do this? Okay, well this should be good. Let's make this blue. Did I do it? What? Oh, did I not change it? There we go. Let's go and erase it. What? Oh, I see now. I see how it's working. That makes sense. Okay. Okay, let's see here. Okay. The other line is 8 is what, greater than 2x minus 5y. I believe that's what it was. In any case, rules doesn't matter that much. We will have, okay, we'll subtract 2x from both sides. 8 minus 2x is greater than negative 5y. Divide by negative 5, and remember, when we divide by a negative number, or multiply by a negative number, then inequality, we have to reverse the sign of the inequality. In order for this to come out in a way that's probably a little better, let's go ahead and reverse the equality here, so we end up with this. Now, let's look at this one. This one will have its intercept at negative 8/5. So let's go ahead and draw that here. Should be about here. Let's see, negative 8/5 plus, let's see, 2/5. We put it next equals 1. Be negative 6/5. So that would go about here. Okay, there we go. Now, the first one says that y is okay, first one says that y is greater than this line. This one here. Second one says that y is less than this line. So y is in these regions. However, it will only lie in the region that's shared by the two, because the first one was a constraint that has to be somewhere here. The second one puts the constraint on that has to be somewhere there. The only region that is shared and satisfies both conditions is this one here, but where the area where they intersect here. Because we had something like this. Would be the region here between them. But yes, and this line must be dotted as well, because it just says less than, not less than or equal to. So we'll go and dot it. Okay, good enough. Okay, so that is how you solve linear inequalities and systems of linear inequalities. So thank you for watching the video. If you want us to make a video on a specific topic, just leave a comment either in the comment section below or on our website, civicschooltutors.wordpress.com, and we will try to fulfill your request as soon as possible. Thanks.